Hi, my name is Brian Batson, and I'm from St. Petersburg, Florida. And this is my submission for the optional assignment for the Spring 2013 offering of Information Security Management at Carnegie Mellon. Today I'd like to talk about Java. And, I think we all have quite a bit of familiarity with that language, if not from a professional environment, then from an academic environment. Here in this program, we have to take programming or object-oriented programming in Java, as well as the follow-on course, Object-Oriented Analysis and Design. And really, I don't think it's any wonder why administration would decide to include Java in these classes. Number one, because I think it's pretty conducive to teaching object-oriented concepts, and number two, just the fact that it's just so enormously popular. Running on over 3 billion devices. Who can argue with that? So, but today we're here to talk about security, and it's interesting to see Java in the headlines so much as of late, in the hot seat really, which is in contrast to a lot of what textbooks would tell you. I have a sample here. Java, a beginner's guide that I picked up a couple years ago, and it has a section on security that I wanted to read. And it says, in order to prevent unauthorized access to system resources, Java confines itself to its execution environment and does not allow access to other parts of the computer. This ability to run Java with confidence is considered by many to be the single most innovative aspect of the language. So you see a lot of confidence in the security of the language, which is quite contradictory to a lot of the headlines as of late. I saw earlier this week Krebs on Security had noted that there were 42 patches with release 7.21 of Java. And back in January, the Department of Homeland Security issued a formal advice to unplug Java from your web browser. So I thought it would be appropriate to dig into exactly what are the black hats are doing with Java to create such a stir. And I found it a little bit difficult to find specifics on the internet, and I can cite maybe two reasons for that, if not more. But number one, either the reporting agency doesn't know the specifics, and they just know the broad, high-level cliff notes, or number two, the press as a whole doesn't want to make it easier for criminals to exploit the vulnerability. So there's a little bit of opinion in that, and it's kind of a topic in and of itself. But I'm in the camp that says go ahead and make all that information transparent. Give the general public and the white hats and the black hats the specifics. And maybe a patch will come out sooner than otherwise, because the black hats are not relying on CNN and Fox News to carry out their exploits. It's all for the most part driven by underground communities with exploit kits that are put together and ready to go. So let's get into what's actually happening as of late. And to understand that, we have to understand three prongs of defense that Java kind of lives off of. Number one is what can be called a bytecode verifier, which just prevents hostile compilers, if you will, from taking down the JVM, which is the Java virtual machine installed on the PC. And number 2 is a class loader, which determines how new classes are added to a running environment, and that prevents critical parts of the program from being replaced by code that Java is running in a browser. And number 3 is the security manager, which is sort of the rule book that the class loader lives by and consults to see if custom code, not native code, but custom code can get through. And a lot of times the security manager will veto the code. But the exploits as of late have used vulnerabilities in the second and third prongs of defense by being able to trick the class loader into thinking that it's receiving native code, when in fact it's receiving custom code, in this case being malicious. And so to be specific, there's a find class method that simply does some stuff and then calls another method called load class. That's in a class called mBean instantiator. And that class exists to handle instantiation and using different loaders and serialization. Now, the vulnerable methods, which are vulnerable because they are considered native code, and this will allow any class, however malicious, to be loaded without consultation from the security manager. Those vulnerable methods exist in a private constructor of the class. So in order to exploit the vulnerability, you need a reference to an instance of that class running in the program. And that, as it happens, can be found in an applet that's running in a web browser that uses another class called mBeanServer. So your exploit would instantiate mBeanServer, then instantiate mBeanInstantiator, and then run the find class method, and passing into that method a class that would otherwise be restricted. So you found your way in. So that's it. Not a whole lot involved, really, relatively speaking. And it's just staggering how little code can be used to cause so much chaos. So we will see where Java goes from here. It's seeing a lot of competition from C# and other languages, but we shall see. So I will sign off with that. Good luck to everyone, and we'll talk to you later.